So how should we be able to determine the nth term for the arithmetic progression? And mind you, the formula for the nth term is given as actually this. Nth term is equal to first term plus the number of terms minus actually 1 times t. So this is the actually a formula for the nth term. And basically the nth term, this is the expression that is actually, this is the expression that we generate in much as we do not have the actually a number of terms. Another is we generate the nth term when actually n is unknown, while the first term has the common difference, they are basically known. Let's say we have this case. Let's say we have AB actually city given us 2, 4, 6, 8, on this way. Let's say up to 2000 should be up to 200 in that range. So what is the nth term formula in the actually for this actually a number city? So first thing, what is the first term? We have it as 2. And what is the common difference? We have it as 4 minus 2, and that is given as 2. Of course, you can also have it as a 6 minus 4. That is the same. So now nth term formula is equal to first term plus a number of terms in the terms the common difference. We can have it as 2 plus n is unknown, and the difference is given as 2, which is the same as 2 plus, or have 2n minus 2, of which we have it as 2n. So this is the nth term formula you have to understand. So which means if we would like to have, let's say, a term on whichever the position, we can be able to use the nth term formula to have that particular term. Let's say if we like to have, let's say a term on position 60. So if that's the case, it means the n will be given as 60. Then actually a term that is 16th term will be given as 60, should be 2 times actually 60. That will be given as 120. So which means for that particular actually a number pattern, the term on position 60 is given as 120. So that's the goodness with the nth term formula. Let's say we have this case. We have, let's say, -2, let's say -5, and that should be, let's say, that case. So what is the nth term for this actually APC? So the first term is given as -2, and the common difference is given as -5 minus -2, that which is equal to -5 plus 2, which is the same as the -3. So now the nth term will be given as, let's say, -a should be -2 plus n minus 1 times negative should be 3, which is the same as -2, and minus 3n plus 3, which is the same as, now we'll have it as a 1 minus a 3n. So this is the nth term formula you have to understand. So in this case, which means if you like to have, let's say, a term on position 100, which we just have to substitute that one into the nth term formula to have that particular actually a value. And what if you have this case? Let's say have, that should be a 2000, let's say should be -2000, this should be this 2000, let's say 1500. Now I should have it this way, 2000, then I'll have 1090, right? Let's say that's, and then actually 1000 should be, let's say 1090, let's say that's the case. So let's say this one represents the number actually city that is in arithmetic progression. Let's say that's the case. So what is the nth term formula for this case? So in this case, we'll have it as the first term given as 2000, and the common difference is given as 1000, should be 1090 minus 2000. That will be given as the negative, that should be -100. So you'll be able to have the nth term formula in that way. So try to proceed that one out. What if we have this case? Let's say we have 2 and 2a should be, let's say, 2q plus 4. And let's say we have 5, let's say 5q minus, let's say, a 6. And let's say we have, let's say this is a typical actually arithmetic progression series, and which is now done this way. So what is the nth term formula and for this particular actually a number pattern? So now you should have to understand that we need to have the value of q first, therefore us to have the nth term formula. So how should we be able to have the value of q if this is the case? So now take it from me. Let's say if we have the actual number pattern given as 2, 4, 6, 8, let's say 10. So the common difference is given as, should be common difference is given as 4 minus 2, of which this is the same as 6 minus 4, of which this is the same as 8 minus 6. In other words, at each and every point, the common difference is the same. So from that perspective, it means this is true. That is, if it is said to be arithmetic progression. So in this case, the common difference will be given as 2q plus 4 and the minus 2 will be equal to, now 2q plus 4, now should be this, or have this one minus 2. Then it means this one minus this one also be the same as the common difference. So now have it as 5q minus 6 and minus now 2q plus 4. That is the essence behind. So which means we'll have it as 2q and plus 2, because 4 minus 2 is given as 2, that which is equal to 5q minus 6. Then we'll have to distribute this negative, and that will be given as negative 2q and minus 4. Having the like terms together, we can have it as, now this 5 and this one will be given as the 3q. So now which means we'll have it as 2q and plus 2, now which is equal to 3q and minus 10. So now have it as 2q minus 3q, which is equal to negative 10 and minus 2, of which you have it as negative q, which is that of equal to, should be 12. So which means the q will be given as a positive 12. That is the value of the q. So take note of that. Will be given as the positive 12 that way. So what is the first term? We know that the first term is given as 2. What is the common difference? Of which we say that it has to be 2q plus 4 and minus 2. That is the common difference. What is the q? We have got it as 12. Have it as 2 times 12 plus 4 minus 2. So that will be given as 24 plus 4 should be now a plus 2. That will be given as 26. So this is the first term, and this is the common difference. Now you can be able to have the nth term formula in that way. So take note of that. Now what if we have this case? Let's say have, let's say m minus 1, let's say 2m, let's say plus 5, let's say have 10m minus 5. Let's say this is the arithmetic progression. So what is the nth term actually formula for this particular actually series? So now principle remains the same. We need the first term as well as the common difference, but I should have to express the values of m first, and first to have the nth term formula, and for this particular actually a series. So what is the principle behind? So in this case we'll have 2m plus 5. Now it should be 2m plus 5 and minus m minus 1 is the same as, now I have 10m minus 5 and minus Now let me have it properly here. So have 2m plus 5 in the minus m minus 1. This is the same as 10m minus 5 in the minus 2m plus 5. So take note of that, and of which you have it as 2m plus 5, and you have to distribute negative there. I'll have it as the negative m and plus 1, which is equal to, we'll have 10m minus 5, and also have to distribute negative there, and of which you'll have it as negative 2m and minus 5. So that is, having the right terms, we'll have now m and plus 6, which is equal to, so for this case we'll have it as 8m and minus 10. So have m minus 8m, which is equal to negative 10 minus 6. We can have it as negative, should be 7m, which is equal to negative now 16. It means m will be given as 16 over 7. So that is the value of m, and of which we can have to substitute that one. So what is the first term? First term is given as the m minus 1. So what is the m we have to substitute? And the common difference will be given as this expression minus this one, of which you have to substitute for m to have the common difference. Then from there you have the nth term formula in that order. So take note of that. Now what if we have this case? Let's say you have it as let's say 2 over negative 5 comma, let's say 4 over, let's say negative 7 by 6 over, let's say negative 9. Should have it this case. So what is the actually nth term formula for this actually a number pattern? So we know that the first term is given as 2 over negative 5. And what is the common difference? We'll have it as 4 over negative 5, actually over negative 7 minus 2 over 5. So this minus, it is this one. So always the common difference has to be obtained upon having subtracting the succeeding value from the preceding value. So that is, so which means we'll have it as 4 over negative 7 plus 2 over 5. So try to have that and now to have the nth term formula there for that case. So now, what if we have the nth term formula? How can you be able to have, let's say, the first term or the term in whichever the position and for the certain a number pattern for the arithmetic progression? Let's say we have the nth term formula given as, let's say, 2n square. So now find the first 10 terms for that particular a number pattern. Find the first 10 terms for that particular number pattern. So how should you have to have that out? So let's start with the first term. So first term, it means n is equal to 1. So in that case we'll have it as, now have it as 2 times 1 to the power 2, which is equal to 2. Then the second term, so should be the second term. So in that case it means n will be given as 2. So have it as, now should be 2 times 2 to the power 2, and which is now equal to 8. So we'll have that and as that. So now which means, and of course it should be, now we should have the nth term formula given as that, not the way it is there. It should be, let's say that's the nth term formula, like that. So now, which means the first term will have the n given as 1. So which means we'll have 2 times 1, which is equal to 2. And how about the second term? We'll have n is equal to 2, of which you have 2 times 2, which is equal to 4. And until you have the first 10 terms. So that is, what if we have this case? Let's say we have the nth term formula given as, let's say, that should be, let's say, 2n minus, let's say, 5. So what is the, let's say, what is 20th term? What is the 20th term? And for the particular number pattern with that, actually with that nth term. So in this case, number of terms is given as 20. If that's the case, it means the 20th term will be given as now 2 times 20 minus 5. You'll be able to have the term on position 20 using that expression. So that is